I'm Rob Kellogg, and this is part 2 of your SDS sheet identification. And what we're going to talk about is now section 9 through 16 and what we need to do in order to understand how to apply all that first 1 through 8 section to our work environment when it comes to chemical implementation into our tasks. So without further ado, let's take a look at those last 9. Section 9 is an extremely important section. Most people overlook it because it says chemical characteristics, the physical characteristics of this chemical. And we start getting into boiling points and atmospheric pressure requirements, things of that nature, vapor densities. It's like, whoa, too much. It's just too much technical information. So let's simplify this so we can actually utilize this section. So if you go to section 9, what I want you to look for are 2 things. If you have a material that is going to off-gas and give that material into the air, we're looking at vapor density. Remember that, vapor density. So if we're going to have another chemical that actually gets into a liquid environment, like water, we're going to be dealing with specific gravity. Those are the 2 terms we're really concerned about. Mainly vapor density. Why? Because most chemicals we're dealing with is not in a water environment. We're dealing with that in an open air environment. So we want to know where that stuff is going to accumulate once we release it from its container. And that's where vapor density comes into play. Understand, we're talking about volume comparison, and this is about weights. Now, if you compare a block of air, square foot, or cubic foot in this instance, to a cubic foot of another section of air, which one weighs more? It's the same. So we're talking about 1-to-1 ratio, okay? Now we're talking about in vapor density comparing a chemical to an air environment. Which one weighs more? So we want to understand that air always is equal to 1, and your vapor density is a variance of weight in comparison to that air. Simply put, which one weighs more? So it's going to give you a number identifier. Don't worry about the other things behind that. We're looking at that number identifier because it's comparing it to 1. If air is equal to 1, and I've got another chemical, which is part CEM, and it's equal to 0.05, it's less than 1 significantly, which means it's lighter. It's going to rise. If I have another chemical and it's at 1.6, that means it's 60% heavier than air, which means it's going to fall. Why is that important? We need to understand that once we release these chemicals into our work environment, whether it's us as a concern or anybody else that's working in the area that can be impacted by it, we need to know the accumulation zone. And that's what section 9 does for us. So simply put, look for vapor density when it comes to your chemicals. So that way we can see where this stuff is all going to be hanging out once it's done. Now, with that information, we can actually go back to sections 1 through 8 and identify, okay, what hazards are our concern, and more importantly, where are we going to be working? Because if you've got something that's 0.05 and you're going to be working in the overhead, where's it going to accumulate? Up there with you. So that's your first concern. Second, is there any other issues? Looking at section 2, does it bother you, and to what point are you going to tear, cry, cough, itch, whatever that may be, or is it going to be even worse? Second, is it flammable? Is it going to catch fire? Since section 5 will tell you what that condition exists to have that happen. And if you have an accidental spill, how's that going to impact you? If you spill it, it's going to accumulate rapidly up in the overhead and could take you out of the game rather fast. So all these things are important to understand beforehand, like we discussed in the previous presentation. But in this instance, now we're talking about accumulation of where that chemical is going to settle and stay until it gets ventilated out of that space or that particular environment. So if it's heavy and goes down to the ground, it accumulates a lot, like in excavation operations or in basement environments, things that are lower level that will fill up like a gas tub, for lack of a better term. Are we going to be working down there? Also, if we're not working down there and we know it's going to accumulate either up or down, we need to know what kind of influences already exist there, potentially could exist. There's heat sources, there's other workers in those environments. How are we opening that container or spilling it? How are we going to affect those individuals in those areas as they perform their tasks? So this is something we need to think about in a broader spectrum, but especially for ourselves. But don't forget anybody else and everybody else that's working around you, because you will impact them as well. So in section 10, we're going to get into stability and reactivity. This is going to tell us how that chemical reacts to other chemicals and other environments. And we have to be very mindful of that. So if you've got a petroleum product and you introduce an oxidizer, oxygen, peroxides, things of that nature, into that other chemical, you're not going to like the results. And a lot of times it's going to get out of hand and things are going to get real bad real fast. So these are things that we would look for in the stability section and reactivity section, section 10. Section 11, this is the toxicological section. And what this tells us is how this chemical will affect our tissues and internal organs. Whether it's our lungs, our kidneys, our liver, whatever that might be, it will tell us which component will impact it, to what degree it will impact it, and what you need to do to protect yourself, referring back to section 8. It also tells you long-term effects of that exposure. So if you don't see the effects immediately, here's what you can expect long-term, like asbestos. So when we get into that, that helps us understand that chemical a little bit more when it comes to our body or our tissues specifically. Section 12, this is going to be our ecological section. Like I said in the previous presentation, this is where the EPA will have this symbol, or the producers of this SDS sheet will put this symbol in order for you to identify which animals, plants, aquatic life, things of that nature will be impacted. Section 13, this is where we get our companies in a little bit of trouble as users of this chemical, and that is the disposal considerations. If you see in section 13, it says that waste management, waste disposal considerations must be implemented, you need to have a third party come and take that particular container and material away. And what they will do is they will neutralize it with another chemical or a series of chemicals and processes, and will neutralize it to a safe material, and then they will dispose of it accordingly. So without that, if you just throw it in the dumpster and it goes out to the landfill and the EPA finds out about it, it's coming back to you pretty hard, so you and the company. So be mindful of that. Section 14, if you take it out on a public road, rail car, airway, boat, anything that is in a public exposed environment, these are the parameters in which you need to set up and accordingly to make sure that they get there safely and they're transported properly. Section 15, this is your regulatory section. This is where management will get involved, identifying what regulations and oversight for this chemical or components within that chemical must be met. Whether it's a state regulation, federal regulation, international, those are all going to be disposed in this particular section. So section 15 is mainly for the management section. Now, if it wasn't covered in any other of the 15 sections that we just discussed in this presentation or the previous one, section 16 is the other or miscellaneous information, and you'll find it there. A lot of times you'll see acronyms like PELs or TLVs, things of that nature within the chemistry of the chemical. And if you're curious about that, more than likely you will find that in section 16 in the legend and describe what that term means or that acronym means. It also gives you information about who put this together, the company that was responsible, any other international symbols or representations that you must be aware of. You'll find that all in section 16. So that pretty much wraps up your SDS sheets. Again, they are standardized, 16 sections, 1 through 16. Internationally, throughout the world, everybody follows this program now. And if you have any questions or concerns, first review this segment. And if you still aren't getting the answers, please call us so we can help you through it. As always, safety is not a mindset. It's a state of mind. Be safe out there.